Welcome back to Rhino JFR Commands tutorial. Today, I will use several examples to continue sharing practical methods for using JFR commands. Let's begin today's lesson. The first command to learn is Skew Twist. It can quickly create this kind of twisted shape. I'll start by making a chain as an example to simply demonstrate how the command works. Create an elliptical curve. Switch to the front view. Click the icon, then drag directly. We can quickly obtain a twisted ellipse. And in the top view, its shape remains unchanged. Then generate a pipe. Draw a curve to create the chain. Use objects on curves. Arrange the links along the curve. Here you can switch to strict. Drag the arrows to adjust the spacing. Here you can edit the size of the links. In this way, a chain is easily created. Now let's go back and use the Skew Twist command to create a twisted design for the ring. Select the ring. Then click the icon. Drag directly. The ring design is created easily, and the side view does not deform. Let's move on to the next example. Creating the shank design for this type of diamond ring is also very simple. Show the control points. Select the upper part of the ring shank. Switch to the right view. Click the icon, then drag to the left. Adjust the middle section a bit. Then adjust the control points of the inner ring back. Move to the left. The control points at this position need to be moved a bit further. This basically completes it. This is the common usage of Skew Twist. In the future, whenever you encounter such designs, you can easily complete them. Next, I will explain the common usage scenarios of Twist command. Rebuild the curve to add more control points. Rotate 45 degrees. Generate a curve between two curves. Scale towards the center. Then use loft to generate a surface. Right-click the icon. Twist this surface. Array 4 in the top view. This produces a spiral shape. After generation, we can keep adjusting the shape. Alternatively, generate a pipe from the curve to create another common design. Revolve 180 degrees. Use JFR pipe. This style is also very common. Then we can continue to adjust the curve, and the pipe will change accordingly. This command can also be used to create models like ropes. Use two curves and then twist them together directly. Finally, generate using JFR pipe. So, that is the common usage of twist. Let's continue to learn how to use the Taper command. Select the object, then click the icon. Drag the arrow. The operation is very simple. Now, I want to create a gradient effect on the sharp edges in the middle. If you directly select the control points to scale, it won't achieve the gradient effect I want. Then we'll need to use another taper command. Right-click the icon. This command can directly taper the control points into a trapezoidal shape, then scale outward on both sides. This way, it'll achieve the gradient sharp edges I want. This is the usage method of the two taper commands. Next is the skew command. It can be used to create rings with interlaced designs. Tilt it vertically first. Then use horizontal mirror. Then adjust them to create a difference in height. Use lasso points. Select the upper control points. Scale outward. Let them gradually form a difference in height. For the other one, scale inward. I suggest that after generating a surface using rail command, then use skew. This makes it easier to adjust. This is the usage scenario for skew. Next, I'll demonstrate how to use Align and center the object. Sometimes, models obtained from external sources may not be arranged neatly. Then we can use the Align command to resolve this issue. The current options have total and all three axes enabled, which is equivalent to moving them. The options we commonly use are group and each. Each will align each object individually. Since all three axes are enabled, aligning to the center, by disabling the Y and Z axes respectively, it will align along the x-axis. Sometimes there are many objects and they are scattered, and only some objects are not aligned. The unaligned parts can be grouped together first by selecting them all. If you use the each option, the ungrouped parts may become misaligned. Then we can use the group option to exclude them. This way, the grouped objects can be aligned individually. But this option isn't used often. The above examples are the usage scenarios of Align. Next is how to use center the object. Sometimes the jewelry models we obtain from files might not be placed at the center of the world, so we can use this tool to quickly place the model to the center. This necklace is treated the same way. This is how to use center the object. Next, I will use several examples to explain how to use the project command. The first example. Now, I will quickly place these gemstone settings onto the surface of the pendant and position them in the direction of the pendant's normal. So we can use the project command to quickly achieve this. Here, I have pre-created a pendant surface using Rail Sweep 2. Click the icon. Select the gemstones and settings as the objects to project. Click on the target surface. The direction is upward. Then set structural form. Fitting is applicable to curves or control points. And keep struct applies to surfaces and mesh objects. The height of the setting attached to this surface is based on the height on the x-axis. If I move the settings downward, the ones above will also move down accordingly. After projection, the surface can be hidden to facilitate observation. Then I'm going to adjust the height of the gemstone settings individually. In this way, we can reduce the process of unfolding and flowing, and achieve the goal directly with projection. It is applicable to the projection of curves, surfaces, meshes, and blocks. Its range of application is very broad. This is one of the usage scenarios of Project. Second example. I will quickly use Project to fit this pattern accessory onto the ring. First, move it upward. Select the ring shank. Set the direction to right. Keep struct. The pattern will directly fit onto the surface. And we can still adjust its position like this. Adjust the height. It's very simple to use. Next, I will explain how to customize the projection direction. Click Project. Here on the interface, you can see there is a custom option. Set the starting point. Set the direction. Finally, adjust the basic shape according to the projection result. This is the second example of Project. Now let's move on to the third example. Sometimes, after repeatedly editing the ring shape, it may become asymmetrical. So, how do we restore symmetry? We can also use Project to restore it. But first, I need to draw the target curve for projection. Vertical mirror. Draw a curve at the sharp edge position too. Now, use the Project command to project the control points onto the curves. You can choose either left or right for the direction. Here, change it to fitting. This way, the control points will perfectly fit onto the curve. Do the same operation on the other side. Next, handle the edge in the middle. Finally, use vertical mirror on the ring. Check if it's symmetrical on both sides. This is a common use case for Project. Finally, I will use an example to explain how the Pull Curve command works. When modeling, we often need to edit curves or control points on surfaces. However, after editing, the control points may no longer adhere to the surface. In that case, we can use the Pull Curve command to fit the curve onto the surface. Select the curve you want to pull. Turn on Fitted to Object. Then click on the surface. This will fit the curve onto the surface smoothly. I'll demonstrate it again. Click the icon. Select the curve, then click on the surface. The fitted curves will not add extra control points, and you can use the rail command to create surfaces normally. This is how the Pull Curve command works. That's all for this video. Thanks for watching this far. If this video was helpful to you, don't forget to like, share, and subscribe to us. See you next time.